All right, guys, welcome to part 2 of section 5.3, talking about rates and unit rates. Today, we're going to start with example 3, finding equivalent rates. Part A says a chef buys 6 pounds of salmon fillets for $51. How much will the chef pay for 9 more pounds of salmon fillets? So in this problem, they give us a rate. We know that we're working with 6 pounds of salmon for a total of $51. So that first rate is given to us in the problem. Now we have to be very careful when we look at our table before we start entering numbers. The first label is cost, so we're working with our $51, and the second label is salmons in pounds. That would be our 6 pounds. So for $51, we get 6 pounds of salmon, 51 to 6. Since this problem is asking us how much will the chef pay to buy 9 more pounds of salmon fillets, we can work with finding the unit rate, or the cost per 1 pound of salmon. Once we know how much it costs for each pound of salmon, we can multiply that by 9 to know how much it would cost the chef to buy 9 more pounds. So in order to turn our rate into a unit rate, we know that we want to find how much it costs for 1 pound of salmon. How can we get from 6 to 1? Well, we divide by 6. So we'll do the same thing to the top, divide 51 by 6. If you plug that into your calculators, you will see that we end up with $8.50 per salmon fillet pound. Since we want to buy 9 more pounds, we're going to then, in our ratio table, write a 9. So we started with our 6 pounds for $51. We know it cost $8.50 per pound. Now if we want to buy 9 more pounds, we're going to take this 1, multiply by 9. Same thing to the top, take our $8.50, multiply by 9. When we do that, we end up with $76.50. And as you can see here off to the side, it says using a ratio table, we can divide to find the unit rate and then multiply to find the cost for 9 pounds of salmon fillets. Now that is one way to do it, finding the unit rate. There is, of course, multiple ways to do this problem, as we've learned throughout this chapter. Since we started with our rate of $51 for 6 pounds, we could always set up a proportion, knowing that we want to find an equivalent rate or ratio of how much it would cost for 9 pounds. We could then cross-multiply as so, in order to find our value of x, which is the amount of money it would cost for 9 pounds of salmon fillets. If you want to pause the video and work out that part of the problem by yourself, you may. You will, of course, end up with the same answer of $76.50 per 9 pounds of salmon fillets. In part B, we have a similar problem. Because up above. You buy 2 pounds of tilapia fillets for $16. What is the cost for 7 pounds of tilapia fillets? Now we could, of course, use our unit rate and ratio table method in order to find how much it would cost for 7 pounds of tilapia fillets, or we could also use our proportion method, or in this case we're actually going to take a look at another way we can do this with our double number line. Reasoning behind that is because 16 is easily divided into halves, fourths, and eighths, it is appropriate to model the rate using a double number line. So we could start by making our number line here with our rate that they give us, 2 pounds of tilapia for $16. So the rate they're giving us is 2 to 16, or we could also rewrite that as 16 to 2 if we're talking about dollars to pounds as they are in the double number line. So across the top, we're looking at all of the dollars, and we would start with this number line by writing $16 for every 2 pounds. If we cut that amount in half, we know then we're dealing with $8 for every 1 pound. If we were to increase that, we would be going up by 8s. As you can see, this increment here would be 8. So if we added 8 to 16 here, it would be $24 for 3 pounds, $32 for 4 pounds. We're going up by 1s now on the bottom. We're going up by 8s on the top. So this is similar to the repeated addition method. Or you could think of it as 8 times 1 is 16, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. Same thing across the bottom, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. We can continue that all the way up until we get to 7, since they're asking us how much would it cost for 7 pounds of the tilapia fillets. So when we get to 7 pounds, the number we're working with above would be 56. Again, this is very similar to the setup of a ratio table. And again, we could of course find this same answer by setting up a ratio table itself or a proportion, knowing again that we're working with $16 to 2 pounds. We want to know how much it would cost for 7 pounds. We could cross multiply with a proportion in order to solve for x. We would of course end up with $56. Let's go ahead down and move on to the on your own section here. Your download speed is 3 megabytes every 4 seconds. So we are dealing with 3 megabytes for 4 seconds. 3 to 4 is our ratio. How many megabytes can you download in 1 minute? Keep in mind, my friends, 1 minute is very different from seconds. So you can go about solving this problem in several different ways. You could transfer this 1 minute, translate it into 60 seconds, and find out how many megabytes you would download in 60 seconds. Or you could find the unit rate, meaning how many megabytes would you download per second, and then multiply that amount by 60. So either of those methods would work fine. Go ahead and give it a try by pausing the video. Once you come back, I'll walk you through my process and we can check and see if you got the answer right. Okay, hopefully you took some time and paused the video to solve this problem. I'm going to solve this problem by setting up a ratio table to find my unit rate. I have 3 megabytes every 4 seconds, so I've got 3 to 4. I want to take a second and practice my unit rate. So I want to find out how many megabytes I would download every second. So to get from 4 to 1, I would divide by 4. So I want to divide the top by 4. I download 3/4 megabyte every 1 second. Now remember, the question's asking us how much we download in 1 minute. So I'm going to take that 3/4 megabyte, multiply it by 60 to see how many megabytes I download in every 60 seconds or every 1 minute. I'll show my work off to the side here. We have 3/4 times 60 over 1. I could divide out some common factors here. I can cancel out my 4 and turn it into a 1 and turn my 60 into a 15. I divided both those numbers by 4. I end up with 3 times 15. I now have 45 over 1. So I know that I would download 45 megabytes for every 60 seconds. Now again, of course, we could solve this by using our proportion method. 3 megabytes every 4 seconds equals however many megabytes in 60 seconds. If I cross multiply like this, I would end up, now I'm going to just take my work up this way, 3 times 60 equals 4x. 180 equals 4x, divide each side by 4. 180 divided by 4, I end up with 45 equals x. Same answer, different method. And finally, we are constructing a double line. This is the second part of the on your own question. Construct a double number line that represents the situation. How many megabytes can you download then in 10 seconds? So we're constructing a double number line that represents that we download 3 megabytes every 4 seconds. I'm going to label my number line first. Zoom out just a tad. Label my number line with M on top, 4 megabytes, and seconds on the bottom. Now I know I'm going to start at 0 seconds, and of course I'm going to download 0 megabytes in 0 seconds. Now I found the unit rate up above here, so I know that after 1 second I download 3/4 of a megabyte, and that was because of the work that we did up above. So in 2 seconds, 3 seconds, 4 seconds, I already know that in 4 seconds, based on the problem, I download 3 megabytes. In order to fill in the rest of my double number line, like how many megabytes I download after 2 seconds, well, if I know that I download 3/4 megabytes every second, I just increased from 1 second to 2 seconds. So at the top, I'm going to increase from 3/4 up, increase another 3/4. I'm doubling the 3/4. So 3/4 megabytes plus 3/4 megabytes is 1 1/2 megabytes. Every 3 seconds, I want to add another 3/4 up top. That's 2 1/4 megabytes. And then we can see that that continues increasing by 3/4 every second because we download 3/4 megabytes every second. I'm going to fill in the rest, 5 seconds, 6, 7, 8, 9, and 10 is where I'll stop because the problem asks me how many I download in 10 seconds. Across the top, I can continue filling in. 3 plus 3/4 is 3 3/4. 6 seconds would be 4 1/2. And then we had 5 1/4. And then we're at 6, 6 3/4, 7 1/2. You can kind of think of it like money, if that helps you at all, thinking of it by adding 75 cents each time. We can see the answer to our question here. For every 10 seconds, after 10 seconds, we would download 7.5 megabytes or 7.5 megabytes per 10 seconds. We can write that answer in here. 7 1/2 megabytes per 10 seconds. It's supposed to be a 10. And as usual, you could have solved this with the proportion method using our 3/4 as the base rate or the initial rate they gave us, and setting it equal to x over 10. We should end up with 7.5 megabytes either way. All right, guys, that's it for 5.3. Please let me know if you have any questions. Good luck with the rest of your work today and with your homework tonight, and continuing to study for the 5.1 to 5.4 quiz coming up. Have a good day.